નમસ્તે મિત્રો, મારું નામ પ્રોફેસર ગિરીશ સી પંચાલ. હું વિશ્વકર્મા સરકારી ઇજનેરી કોલેજ ચાંદખેડા ખાતે સહાયક પ્રાધ્યાપક ગણિતશાસ્ત્ર વિષયમાં ફરજ બજાવું છું. મિત્રો, આપણે અહીંયા જીટીયુ ખાતે સેમેસ્ટર 3માં ડિગ્રી એન્જિનિયરિંગમાં ચાલતો અભ્યાસક્રમ પ્રોબેબિલિટી એન્ડ સ્ટેટિસ્ટિક્સ જોઈ રહ્યા છીએ, જેના આ અગાઉ આપણે કુલ 1 થી 9 સેશન્સ જોયા. એમાં અલગ અલગ પ્રકારના સંભાવના વિતરણો એટલે કે પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન્સ જોયા છે. એમાં આપણે કેટલાક ડિસ્ક્રીટ ટાઈપના અને કેટલાક કન્ટિન્યુઅસ ટાઈપના પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન જોયા. આ અગાઉ આપણે છેલ્લે એક્સપોનેન્શિયલ ડિસ્ટ્રીબ્યુશન જોયું હતું, જે કન્ટિન્યુઅસ ટાઈપનું પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશન હતું. આજે આપણે ગામા ડિસ્ટ્રીબ્યુશન જોવા જઈ રહ્યા છે. તો આ ગામા ડિસ્ટ્રીબ્યુશન શું છે અને એના મીન, વેરિયાન્સ વગેરે અને એને કેવા કેવા પ્રકારની એપ્લિકેશન સાથે આપણે એનો ઉપયોગ કરી શકીએ છીએ એ આપણે આજે જોવાના છીએ. સો ચાલો આપણે આજનું લેક્ચર શરૂ કરીએ. તો મિત્રો, આપણું આજનું જે સેશન છે એ છે ગામા ડિસ્ટ્રીબ્યુશન ઉપર, એટલે કે એને ગામા વિતરણ કહીશું. અને આજનું આ જે આપણો સ્પેશિયલ પ્રોબેબિલિટી ડિસ્ટ્રીબ્યુશનનો ટૉપિક છે એનું આજે છેલ્લું લેક્ચર છે. તો સૌ પ્રથમ તો આપણે આને ગામા વિતરણ કેમ કહેવાનું છે એને સહેજ જોઈ લઈએ. જેના માટે આપણે ગામા ઉપરથી ગામા ફંક્શનનું થોડો ખ્યાલ મેળવી લેવો પડશે. તો સૌ પ્રથમ ગામા ફંક્શન શું છે એ આપણે જોઈ લઈએ. સો મેથેમેટિક્સમાં ગામા ફંક્શન આપણે પહેલાં ડિફાઇન કરી લઈએ. સો ફોર n positive we define gamma n. This is read as gamma n. Okay. So gamma n is a function that is defined as from 0 to infinity e raised to minus x into x raised to n minus 1 dx. So that is the gamma function, and this is an improper integral. Now we have some properties of this gamma function, that if we replace n by n plus 1 into this and simplifying the integral, we can have n gamma n. So this is true for all n positive. And again, if n belongs to n given, that is n is a positive integer, then we can say n into, and again this property will be applied for this gamma n, that is n minus 1 into gamma n minus 1. Again we simplify and again reuse the same property. So n minus 2 into gamma n minus 2 and so on. We will get 3, 2, 1 into gamma 1. So actually this is n factorial into gamma 1, and again we remember that gamma 1 is 1. So if we replace here n equal to 1, then we can evaluate the integral and we can have gamma 1 equal to 1. So if we put here the value, we will get n factorial. So finally we have gamma n plus 1 is equal to n factorial if n belongs to n. So this is one more property. Then after, suppose we want to find values of some gamma function. So say gamma 5. So 5 is integer, therefore we can say it is 4 factorial. Same way, suppose we are given gamma 2, that is 1 factorial. Same way, suppose we have to find gamma 5 by 2. So here we cannot write 3 by 2 factorial, we cannot write this. So here what property we have to use? We know that gamma n plus 1 is n into gamma n. So that property we will use here. So 5 by 2, so 1 less, that is 3 by 2 into gamma 3 by 2, this property is useful, and therefore again we use the same property for gamma 3 by 2. So it is 1 by 2 into gamma 1 by 2, and again we take 1 less from 1 by 2, that is negative number. So we stop here, and now we simplify 3 into 1, that is 3, here 2 into 2, that is 4, and gamma 1 half is root pi. So if we put n equal to 1 half into the definition, we will get gamma 1 half as root pi. So, this is the value for gamma 5 by 2. So, this way we can find the values whenever we need the such kind of values. Now, if before introducing the gamma function, we just recall exponential distribution. So, here in exponential distribution, what is the random variable? So, x is waiting time until the first event occurs, and which is given by f x equal to lambda e raised to minus lambda x for x positive and 0 for x negative. So, here the random variable x is waiting time until the first event occurs, but in the gamma distribution, what is the difference here? So, let us see, here we define x, suppose, then it is nothing but the waiting time until some alphath event occur. Here our alpha will be greater than 1, we can take 1 also, but when we take alpha 1, it follows the exponential distribution. So, here our alpha is normally greater than 1, but here I have written alpha is greater than or equal to 1. So, for alpha 1, it follows the exponential distribution. So, here suppose we want to find the waiting time until some alphath event, that means until second event, say second car arrival, third event, or say some 12th event, etc. So, such kind of event suppose we want to find, and here we want to find the waiting time until some alphath event occur, then we use gamma distribution, whereas the exponential distribution is used when we want to find the probability for the waiting time until the first event occur or two successive event occurs. So, here we first of all define the PDF of gamma distribution, and then we will see some properties of that. So, the PDF is defined as f x lambda to the power alpha upon gamma alpha x to the power alpha minus 1 into e raised to minus lambda x. This is for x greater than 0 and it is 0 for x less than 0, and here also we can say lambda is positive and alpha is also positive. So, this is the PDF of the gamma distribution, and just we have seen that for alpha equal to 1, if we put alpha equal to 1, this star implies the f x is equal to, if we put alpha 1, that is lambda raised to 1, that is lambda, x raised to alpha minus 1, that is x raised to 0, that is 1, and e raised to minus lambda x, and here alpha is 1, therefore, gamma alpha, that is gamma 1, and that is also 1. So, we have this one for x greater than 0 and 0 for x less than 0, and which is exponential distribution. So, here we have seen that gamma distribution is nothing but the generalization of exponential distribution. So, gamma distribution is thus the generalization to the exponential distribution. So, we use alpha greater than 1, then it is different than the exponential distribution. Here we are using two parameters, lambda and alpha. So, lambda and alpha are parameters for the gamma distribution, where we can say alpha is number of events for which we are waiting, and that is also called shape parameter. Same way, lambda is called rate of the events occurring, or we can say average number of events occurring per time, that is per unit of time, and which is known as rate parameter. So, whenever we know alpha and lambda, we can find the gamma distribution and we can have the properties of the gamma distribution. Now, if alpha belongs to n, then gamma distribution is known as Erlang distribution. So, for alpha integer, we can say the gamma distribution is nothing but the Erlang distribution. This is for our knowledge. Now, there are some applications for which we will use the gamma distribution. So, let us see for what kind of problems we will use the gamma distribution. So, first of all, we have to know that gamma distribution is applied for right skewed data. Now, right skewed data means what? So, suppose the distribution is like this. Okay. So, here there is a tail extended to the right side towards infinity. So, exactly at the peak, okay, this is the mode. So, this is mean. So, mode is not equal to mean and mean is toward the right side of the mode, and in this case it is right skewed data. So, for such kind of distribution we can use the gamma distribution. Secondly, gamma distribution is used to model cancer rates, insurance rates, and rainfall. So, such kind of problems can be solved by using the gamma distribution. Moreover, it is also used to model failure rates or failure time, waiting time, or you can say service time. Most frequently, we use this gamma distribution so the use is to model the time between independent events, and they are alpha that occurs at a constant average rate, and that rate is known as lambda. So, for such kind of problems we can use gamma distribution. Moreover, we can say that gamma distribution can model the elapsed time between various or any number of events. Conversely, the exponential distribution can model only the time until the next event, such as next accident or next earthquake, etc. So, this is the main difference between gamma and exponential distribution. So, here normally we will use two type of distributions and two type of forms. So, there are two forms for gamma distribution. So, the first is for alpha and lambda. So, alpha is a shape parameter and lambda is rate parameter, where lambda is nothing but average number of events occurring per unit time. So, when these two datas are given, we can have the distribution f x as lambda to the power alpha x to the power alpha minus 1 e raised to minus lambda x upon gamma alpha for x positive, and this is 0 for x negative. So, here we can use this is for alpha and lambda, and secondly, suppose we are given alpha as a shape parameter and beta, we will define beta as 1 upon lambda. So, this is defined as 1 upon lambda and that is called scale parameter. So, it means that it is mean waiting time between the events. So, when you are given a scale parameter and shape parameter, we can use alpha and beta, and therefore, this distribution is reduced to f x equal to. So, what we have to do? We just have to put lambda equal to 1 upon beta, because beta equal to 1 upon lambda. So, lambda equal to 1 upon beta. So, we put this value in the above distribution. So, we will get 1 upon beta raised to alpha into gamma alpha x raised to alpha minus 1 and e raised to minus x by beta. This is for x positive and 0 for x negative. So, before solving the problems, we just understand how to decide the parameters when some problem is given. So, this is very important, how to decide parameters. So, let us consider a case. Suppose we measure the time between accidents in a day, and suppose one accident is occurring every 4 days on an average. So, from this information, what data is given to us, how to decide the parameters, let us see. So, first of all, here we are measuring the time between accidents. So, here this time between accidents is nothing but the random variable. So, the random variable is nothing but the time between accidents. Now, accidents are maybe any events. So, we can generalize as events. So, time between events is nothing but the random variable. Now, what is given next? Suppose one accident is occurring every 4 days. Okay. So, here suppose days are 4, then accidents, the number of accidents are 1. So, how many accidents are there in one day? So, that is 1 by 4. So, here why we need this? Because we have to find suppose the value of lambda. So, lambda is nothing but average number of events. Events here are accidents. So, average number of events occurring in unit time. Unit time means in a day. So, in one day we have found that 1 by 4 accidents occurs. So, this is the value of lambda, and therefore, suppose we want to find beta. So, beta is 1 upon lambda and that is 4. So, what is that? 4 is the mean waiting time between the events. that means between the accidents. So, what is the mean waiting time between two accidents? So, average there are one accident in 4 days. So, 4 days is the mean waiting time for single accident. So, between two accidents there is mean waiting time 4 days. So, this is the value of beta. So, in this way we can find lambda and beta, and alpha is given to you whenever some problem is there. Now, before solving some examples, we need to have some basic information about gamma distribution. So, first of all, let us see what is mean of gamma random variable x. So, the PDF for gamma distribution is given by f x, and that is lambda raised to alpha into x raised to alpha minus 1 into e raised to minus lambda x divided by gamma alpha when x is positive and 0 when x is negative, and here we consider alpha is positive and lambda is also positive. Now, mean mu equal to expected value of x. So, let us see what is that. So, integration from minus infinity x into f x dx, but for x negative the value of f x is 0. So, we have only integration 0 to infinity x into lambda to the power alpha upon gamma alpha x to the power alpha minus 1 e raised to minus lambda x dx. So, we have put the value of f x here, and now let us simplify this integral. So, here you see that this part is constant. So, we can take it outside from the integration. So, lambda to the power alpha upon gamma alpha we can take outside, and in the integration 0 to infinity x to the power alpha e raised to minus lambda x dx. Now, we just simplify here, we can take lambda x equal to t, and therefore, x equal to t upon lambda, and therefore, dx is equal to dt upon lambda, and the limit of x is from 0 to infinity, and therefore, limit of t is also from 0 to infinity. So, we put these values here. So, what happens? So, this integral turns out to be lambda to the power alpha upon gamma alpha as it is, again 0 to infinity, x equal to t upon lambda to the power alpha and e to the power minus t, and dx is equal to dt upon lambda. Now, here you see lambda to the power alpha upon gamma alpha as it is, here lambda raised to alpha and lambda. So, that is 1 upon lambda raised to alpha plus 1 outside, and the integration 0 to infinity e raised to minus t and t raised to alpha dt. So, simplifying, we have 1 upon lambda into gamma alpha, and this is 0 to infinity e raised to minus t raised to alpha plus 1 minus 1 dt, because we know that definition of gamma function is 0 to infinity e raised to minus t raised to n minus 1 dt. Here n equal to alpha plus 1. So, this is nothing but 1 upon lambda gamma alpha as it is, and this is nothing but gamma function of alpha plus 1. Now, gamma of alpha plus 1 is alpha into gamma alpha, this is lambda into gamma alpha, again gamma alpha is cancelled. So, alpha upon lambda. So, this is mean. So, this way we can find the mean of the gamma distribution. Now, we use the gamma distribution to find variance. So, variance of x is expected value of x square minus expected value of x whole square. Again from minus infinity to infinity, x square f x dx minus, and just now we have found the expected value of x as a mean, and that is alpha by lambda. So, it is a square as it is. Now, again for x negative the function is 0. So, we just write from 0 to infinity here x square into the f x. F x is lambda to the power alpha upon gamma alpha x to the power alpha minus 1 into e raised to minus lambda x dx minus alpha upon lambda square as it is. Again evaluating this, so taking constant this lambda raised to alpha upon gamma alpha outside 0 to infinity x to the power alpha plus 1 into e raised to minus lambda x dx. Again taking the substitution lambda x equal to t, dx equal to dt by lambda, and therefore, this integration will turn out to be lambda raised to alpha upon gamma alpha, again 0 to infinity x equal to t upon lambda to the power alpha plus 1 e raised to minus t, and dx will be dt upon lambda. So, here lambda raised to alpha upon gamma alpha 1 upon lambda to the power alpha plus 2 outside, and the remaining is integration 0 to infinity e raised to minus t, t to the power alpha plus 1. Now, alpha plus 1 can be written as alpha plus 2 minus 1 dt, and therefore, here lambda raised to alpha is cancelled. So, in the denominator lambda square is there into gamma alpha, and this portion is nothing but gamma alpha plus 2. So, gamma alpha plus 2 is nothing but alpha plus 1 into alpha into gamma alpha, and the denominator is lambda square into gamma alpha. So, gamma alpha is cancelled from here, this gamma alpha is cancelled. So, remaining part is alpha into alpha, that is alpha square plus alpha divided by lambda square. One more thing is left here, we can see that minus alpha upon lambda square is there, this is alpha upon lambda square is there, minus alpha upon lambda square is there. So, alpha square minus lambda square. So, here it should be minus alpha square, and now these two terms are cancelled, we left with alpha upon lambda square. So, this is variance of x. So, variance is nothing but sigma square, and therefore, standard deviation sigma is nothing but root alpha upon lambda. So, in this way we have found mean, variance and standard deviation. Now, we know that mean mu equal to alpha upon lambda and 1 upon lambda equal to beta. Therefore, mu equal to alpha, and this is 1 upon lambda, and that we can put beta. So, mu equal to alpha into beta, and same way sigma square, that is variance, is alpha upon lambda square and 1 upon lambda equal to beta, that is alpha beta square. So, we have some different rules here. Now, we will see some examples for gamma distribution to understand it. So, example, given gamma random variable x with alpha equal to 3 and lambda equal to 2. Compute mean, variance and probability of x less or equal to 1.5 years. Here time is given in years. So, for gamma distribution, what is given to us? We are given alpha equal to 3 and lambda equal to 2. Now, if we want beta, then beta is 1 upon lambda, that is 1 by 2. So, whatever two things we can use, either we go with alpha and lambda or we can go with alpha and beta. So, here we just go with alpha and lambda. So, the PDF is f x equal to lambda to the power alpha upon gamma alpha x raised to alpha minus 1 into e raised to minus lambda x. This is for x positive and 0 if x negative. Now, we just put the value of alpha and lambda into this. So, our probability density function is lambda equal to 2. So, 2 raised to alpha and that is 3. So, 2 raised to 3 upon gamma 3 x raised to alpha minus 1, that is 2 minus 1, and that is alpha minus 1, that is 3 minus 1, that is 2. So, x square e raised to minus lambda x, lambda equal to 2, that is minus 2 x when x is positive and 0 when x is negative. More we simplify, it is 2 raised to 3, that is 8 upon gamma 3, that is 2 factorial, that is 2. So, 8 by 2, that is 4. So, 4 x square e raised to minus 2 x when x is greater than 0 and 0 when x is less than 0. So, this is the PDF. Now, first is mean. So, you know the mean is given by alpha upon lambda, we just have proved. Now, alpha equal to 3 and lambda equal to 2. So, 1.5 years is the mean. Next, variance, sigma square is given by alpha upon lambda square, that is 3 upon 2 square, that is 3 by 4, and that is 0.75 years. So, this we have found. Now, we find the probability. So, third, the probability for x less or equal to 1.5 years. So, what is that? Here we have to integrate from 0 to 1.5 f x dx, because from minus infinity to 0 f, that is 0, because f is 0 for x negative. So, we just do it. Let us put the values. So, the 0 to 1.5, and we have seen this is 8 by 2, that is 4. We just have proved this is 4 x square e raised to minus 2 x dx. So, we just take 4 outside and integration of x square into e raised to minus 2 x. So, we use integration by parts. So, x square into e raised to minus 2 x upon minus 2 minus derivative of x square 2 x, again integration e raised to minus 2 x upon 4 and plus 2 e raised to minus 2 x upon minus 8, and then we put the limit 0 to 1.5. Now, simplifying this, first of all we write 4 as it is, we put 1.5 here. So, 1.5 square, and this is e raised to 2 times 1.5, that is minus 3 upon 2, and this is minus sign because this is minus 2, minus 2 into 1.5, that is 3, e raised to minus 3 upon 4, this is minus 1 by 4 e raised to minus 3, and now we put 0. So, for 0 this x square is 0, this minus 2 x is 0, just we left with the last term plus 1 by 4 e raised to 0. So, simplifying, we can have 4 and e raised to minus 3 common from the first 3 terms. Also I can take 4 outside. So, I just multiply by 2 with the first term. So, 1.5 square, that is 2.25, and multiply by 2, that is minus 4.50. Second term is minus 3 and then minus 1, and last term just I multiply by 4, 4 into 1 by 4 is gone, and e raised to 0. So, that is plus 1 by 4 into 4 1, and e raised to 0 1, that is 1, and we simplify, this is 1 minus 8.5 e raised to minus 3, and that is 0.5768. So, this is what the probability we need. So, હજુ એક એક્ઝામ્પલ જોઈએ આપણે. તો ડિટેલ એવી છે કે ઇન અ સર્ટેન સિટી the daily consumption of electric power and that is measured in millions of kilowatt hours. So, that power consumption can be treated as random variable having gamma distribution with alpha equal to 2 and beta equal to 3. So, this much information is given. Again it is given that if the power plant of this city has daily capacity of 1.2 million kilowatt hours. So, the question is, what is the probability that this power supply will be inadequate on any given day. So, that we have to find. Also find mean of this probability distribution. So, what is given? Let us see again. here we just read it carefully. So, what data is given? So, first of all, consumption of electric power and the unit is in millions of kilowatt hours. So, these consumptions can be treated as random variable. So, random variable is given, that is called daily consumption of power. So, let us write that. First of all, the gamma random variable is x, that is daily consumption of power, and that is measured in millions of kilowatt hours. So, that is the random variable and it follows the gamma distribution that is already given, and here we are given also the value of alpha 2 and value of beta 2. Now, the distribution is f x is equal to, okay, here we are given alpha and beta. So, we use the distribution in form of alpha and beta. So, that the second form, that is 1 upon beta raised to alpha into gamma alpha x to the power alpha minus 1 e raised to minus lambda x, and this is for x positive and 0 for x negative. So, this is given to us, and here alpha and beta is given. So, just we put the value here. So, beta equal to 2, beta is 3 given. So, we just put 1 upon 3 raised to 2, that is 9, gamma alpha, that is gamma 2, that is 1, x to the power alpha minus 1, that is x, and e raised to minus lambda x. Now, beta is 3, therefore, lambda is 1 upon beta, and therefore, this is 1 by 3. So, here we put lambda equal to 1 by 3. So, that is minus x by 3, and this is for x greater than 0 and 0 for x less than 0. So, this is what the gamma distribution. Now, given that the daily capacity of power plant is 1.2. So, given the daily capacity of power plant is 1.2 million kilowatt hours. And what is the question? Just read it. What is the probability? Our question is to find what is the probability that the power supply will be inadequate. So, when will be it inadequate? Inadequate એટલે કે insufficient ક્યારે હશે? તો જે પાવર સપ્લાય 1.2 મિલિયન કિલોવોટ પર અવર એ ડેલી કેપેસિટી છે જનરેટ કરવાની, જો કન્ઝપ્શન એના કરતાં વધારે હોય એના કરતાં, ત્યારે જ એને એમ કહેવાય કે ઇનએડિક્વેટ થાય. એટલે આપણે શું કરવાનું થશે? અહીંયા આપણે પ્રોબેબિલિટી જે ફાઇન્ડ કરવાની છે, તો ડેઇલી કન્ઝપ્શન જે છે એક્સ એ જો 1.2 કરતાં વધારે હશે ત્યારે એમ કહી શકાય કે એ ઇનએડિક્વેટ પાવર સપ્લાય થશે. એટલે આપણે જે પ્રોબેબિલિટી ફાઇન્ડ કરવાની છે એ 1.2 કરતાં વધારે છે એની ફાઇન્ડ કરવાની છે. સો હિયર if the daily consumption, that is x, is more than the production, the daily production is 1.2 unit, whatever unit of time, then we say that the power supply is inadequate. So, that means we need to find probability of x greater than 1.2, and therefore, probability of x greater than 1.2 is integration 1.2 to infinity f x dx. Now, we just have found f x. So, let us put the value 1.2 infinity, that is 1 by 9 x into e raised to minus x by 3 dx. So, we integrate this and get the answer. So, let us see what happens. You see 1 by 9 outside, and here we take integration by parts. So, x as it is, the integration is e raised to minus x by 3 upon minus 1 by 3 minus 1, again integration is e raised to minus x by 3 upon again minus 1 by 3, that will be 1 by 9, limit is 1.2 to infinity. Now, this 1 by 9 as it is, here we multiply this 3 with this, that is minus 3 x, and 9 is here. So, minus 9, and we take e raised to minus x by 3 common with this, and then we have to put the limit 1.2 to infinity. Again we say 1 by 9, this is minus times 3 x plus 9 e raised to minus x by 3, limit is 1.2 to infinity. Now, putting the limit, we get 1 by 9 as it is, infinity limit will give the answer 0, because e raised to minus infinity is 0. So, first is 0, then minus minus plus 1.2 is multiplied with 3, that is 3.6 plus 9, and this is e raised to minus 0.4, and simplifying this is 0.9384. So, here the probability is 0.9384 for the power supply will be inadequate in the city. Next is mean. So, the mean is given by alpha into beta, because you know mu is alpha upon lambda and 1 upon lambda is beta, that is alpha into beta. So, alpha is given and beta is also given. So, we can find the mean in this way. Similar way, let us take one more problem. Suppose that the time it takes to get service in a restaurant or hotel follows a gamma distribution with mean 8 minutes and variance 32 minutes. Suppose you went to hotel at 6:30 p.m. Now, what is the probability that you will receive service before 6:36 p.m. So, that is the problem. Now, we will solve this by using gamma distribution, and it is already given that the time it takes to get service obeys the gamma distribution. So, here we define x as time it takes to get service, and that time we measure in minutes. Also, it is given that mean mu is equal to 8 and variance sigma square is 32. So, first of all we have to find lambda, alpha and beta. So, for that we see mu is equal to alpha into beta and sigma square is alpha into beta square. So, we find alpha and beta from this. So, first of all alpha beta square upon alpha beta, that is variance upon mean. So, if we find it, so alpha beta square, that is 32 and alpha beta, that is 8, and that implies beta is 4, and alpha beta equal to 8, that implies alpha equal to 8 by beta and beta is equal to 4, therefore 8 by 4 and that is 2, and this way we have got alpha equal to 2. So, we have got alpha and beta as 2 and 4 respectively, and therefore, the PDF for gamma distribution is f x equal to, so we have alpha and beta, so we use the distribution in form of alpha beta. So, 1 upon beta to the power alpha into gamma alpha x to the power alpha minus 1 and e raised to minus x by beta, and this one is for x positive and this one is for x negative. If we put the value of alpha and beta here, so 1 upon beta raised to alpha, so 4 raised to 2, gamma alpha, that is gamma 2, x to the power alpha minus 1, that is x, and e raised to minus x by beta, that is minus x by 4, and this is for x positive and 0 when x is negative. So, this is what the gamma distribution. Again simplifying something more, this is 1 by 16 because gamma 2 is 1 factorial and that is 1, x into e raised to minus x by 4, and this is for x positive and 0 for x negative. Now, we need to find probability of getting service before 6:36 p.m. Now, initially we are there at 6:30 and we will get the service at 6.36. So, how many minutes are there? So, the distance is 6 minutes. So, we will get service in 6 minutes, that probability we have to find. So, actually this is nothing but the time takes to get service is less than 6 minutes. So, P of x less than 6, this we have to find. So, let us see how to find it. Integration 0 to 6 f x dx, integration from 0 to 6, f x is 1 by 16 x e raised to minus x by 4 dx. So, 1 by 16 we take it outside. Now, integrating x as it is, e raised to minus x by 4 divided by minus 1 by 4 minus 1 into again e raised to minus x by 4 divided by 1 by 16, and we put the limit 0 to 6. So, 1 by 16, here this is minus 4 x into e raised to minus x by 4, this is minus 16 e raised to minus x by 4, limit 0 to 6. Again simplifying, if we take 4 common, so and x plus 4 will be there, e raised to minus x by 4 is common in the bracket, this is 1 by 4. If take minus outside, this is minus 1 by 4 and put the limit 6 and 0. So, first of all we put 6. So, 6 plus 4, 10 into e raised to minus 6 by 4 minus 0. So, e raised to minus 0, that is e raised to 0 and that is 1, and x equal to 0 will give you only minus 4. And if we simplify, we will get this is 0.4423. So, this is the probability that the service time is less than 6 minutes. That means, you will get service before 6.36 p.m. that probability is 0.4423. Now, we end up here with some summary of the distributions. So, first of all we know we have seen discrete type of distribution, and in discrete distributions first we have seen binomial distribution, and that binomial distribution we are given by probability mass function f x equal to p x equal to x, and that is nothing but n c x p to the power x and q to the power n minus x, where p is the probability of success. Same way in Poisson distribution, the probability mass function what we have seen f x as p x equal to x. Here we just can write p x equal to x only. So, there is no need to mention f x, just p x equal to x, and that is e raised to minus lambda into lambda to the power x upon x factorial, and here lambda is the parameter. Same way we have seen continuous type of random variable, and same way continuous probability distributions. So, what are the continuous type of probability distributions we have seen earlier? So, the first is normal distribution, and the normal distribution is given by the probability density function f x as 1 upon sigma root 2 pi e raised to minus 1 by 2 x minus mu by sigma whole square, and this is for minus infinity to infinity. Or suppose we write f z. So, standard variate z is there. So, 1 upon root 2 pi e raised to minus z square by 2 when minus infinity to z to infinity. So, that is the normal distribution, and then after we have seen in last lecture the exponential distribution. So, the PDF of the exponential distribution is f x, that is lambda e raised to minus lambda x for x positive and 0 for x negative, and in today's session we have seen gamma distribution, and for that the PDF is f x equal to lambda to the power alpha upon gamma alpha x to the power alpha minus 1 e raised to minus lambda x when x is positive and 0 when x is negative. Or if we have alpha and beta, then the PDF is like 1 upon beta to the power alpha into gamma alpha x to the power alpha minus 1 e raised to minus x by beta when x positive and 0 when x negative. So, here this is the summary of the unit 2. So, now we end up with કન્ક્લુઝન. તો મિત્રો આજના આપણા આ છેલ્લા લેક્ચરમાં આપણે ગામા ડિસ્ટ્રીબ્યુશનનો અભ્યાસ કરેલો. ગામા ડિસ્ટ્રીબ્યુશનનું આપણે એનું જે ડિફરન્સ છે એક્સપોનેન્શિયલ ડિસ્ટ્રીબ્યુશનથી એ કેમ અલગ પડે છે એ જોયું. ત્યારબાદ આપણે એના મીન, વેરિયાન્સ વગેરે જોયા અને કેવા પ્રકારના એક્ઝામ્પલ્સ, કેવા પ્રકારની એપ્લિકેશન્સ જે ગામા ડિસ્ટ્રીબ્યુશન અનુસરે છે એના એક્ઝામ્પલ્સથી આપણે સમજ્યું. ત્યારબાદ છેલ્લે આપણે અત્યાર સુધીના યુનિટ 2માં જે કઈ પ્રકારના ડિસ્ટ્રીબ્યુશન જોયા હતા એની સમરી પણ જોઈ. તો આ સાથે આપણું યુનિટ 2 અહીંયા પૂર્ણ થાય છે. જય ગુજરાત, જય હિન્દ.